7.3. Okay, last class we finished calculation about the mean and the sample standard deviation, and now we need to calculate the t-value, the t-value, and here, okay, sorry, something wrong with this. Yeah, okay. Okay, since we have those two data, and now we try to calculate the t statistics, and now and the formula look like this: t equals x mean minus the sample mean and divided by s square root of n. And now we know one thing. Here. We just got the answer x bar, that is 145.4, and according to the question, the average IQ is 100. Oh, sorry, 100. Okay, and now we got the sample standard deviation, that is 29.27, and then divided by square root of 20. Okay, and now who can calculate this? Who can calculate this by typing the computer calculator? Okay, who can calculate this? This one, and got the answer 6.937. Okay, who want to try this? This one. Just you can use the calculator from the software on the computer. Calculate this one, and you suppose you will get a 6.937. Get it? How to calculate by your calculator on your computer? There are several ways. Let me explain here. First of all, you can use the parentheses 145.4 minus 100. Sure, if you know that is 100, that's okay. And slash divided by 29.27, and 29.27 divided by square root of 20. But you know the whole denominator is this one. Thus, you need change the division becomes multiplication, or you can still use the division, but you can have a parenthesis here. Get it? Again. Before the division, here is the numerator as this one. The big denominator look like this: 29 0.27 divided by square root of 20, and you can have a pair of parentheses to place this one as a denominator. Please prevent just the type of the division. Otherwise, it will change the number. I'll change the number. Okay, let me have his. Okay, after that, we got this number here. I got a number here. Or you can do that again. You can do that again. The same one. If you remove the parentheses, and here the denominator in the denominator, it becomes a numerator. So here you place a multiplication here. You will get the same answer. Click it. See, we get the same answer here. Okay, so this part, the same way to calculate this one. Yes, please type this one. If you forget how to calculate by the calculator, you can use this way. Okay, 1 minute, then I will move to the next question. Okay, it's not a conflict, so don't worry. For example, I can do that. I can do that. Insert. See, I placed the calculation and how to type my calculator on my notes. Okay, and next question, and now it becomes a little bit hard here. The p-value, how to calculate the p-value? First of all, we need to get the degree of freedom. We need to get a degree of freedom. That is degree of freedom n minus 1. 20 minus 1, that will be 19. And according to the calculation, the p-value is 6.5 times 10 to the minus 7, and the p-value is this one. P-value is this one. Okay, so the p-value is less than 5%, then reject H non. It means there is enough evidence to show that famous people have a higher IQ than the average IQ of 100. And now I have a question. Do you know how to get the value, p-value? How to get a p-value? What does it mean? The probability, p is for the probability. And the probability 6.5 to the 10 to the minus 7 is very, very small. Very, very small. It means, yes, they are different. Those famous people are smarter than the average. That's conclusion. But now, my question, how to get the p-value? First of all, it's easy to get the degree of freedom. You just take the whole number, n. That is 20. Minus 1, that is 19. Okay, and how to get the p-value? There are several ways. I introduce a tool for you. For example, this one. Distributions.com, like this one, 6.9. Okay, 好吧 6.9 37. Okay. Oh, okay. This one seems. Oh, that's horrible. Okay. Degree of freedom, 19. Please go. No, okay. Oh, sorry. Let me find a appropriate. Okay, and here's another t-distribution table. Okay, let me copy and paste to you. And how to read this one? Oh, for example, we want to know the one tail 0.05, 5% here. One tail that's here, and we want to know the t-distribution, the degree of freedom, that is 19. That's 19 here. And for the one tail 0.05, the value is t-value is 1.729. If we get a number greater than 1.729, it means it's over the 5%, and the distribution is very close to the other end. And we know that. Okay, this. Sorry. Okay. So since we get the answer 6.9, that is greater than 1.729. It means it's over the criteria. over 0.05 is very, very big. It's very, very big. Okay. Thus the conclusion is there is enough evidence to show the famous people have a higher IQ than the average IQ of 10. Sorry, of 100. Okay. Then next move. Sorry. An example, test of sample mean using technology. This one. Okay, I think you can practice as at home. And here is the homework. 97. What does it mean? About how to reduce the carbon dioxide emission like this one. Okay, I think I can stop here, then we can move. Any answer here? Answer. Q1. Fail to reject. Okay, any question? Sure. In the final exam, I will have at least one question about the 7.3, the one sample test for the mean. Okay, let's move to next. Nope, maybe. Sorry, I think we can have one more question about this. Okay, how about this? Practice this one, exercise 7.3.1. Okay, then the Tokyo Protocol was signed in 1997. Are required countries to start reducing their carbon emission. The protocol became enforceable in February 2005. In 2004, the mean carbon dioxide emission was 4.87 metric tons per capita. The table is here. Contains a random sample of carbon dioxide emission in 2010. The carbon dioxide emission here. Okay. Is there enough evidence to show that the mean carbon dioxide emission is lower than 2010 than in 2004? Test at 100 level. Okay. And now please practice this one. Again, let me. Okay, 3 minutes. If you forgot how to do this, you can check the example as we shared here. This one. questions? How to calculate this one? Very similar as the example I shared. Okay, let me show you how to do this. Yeah, we can imitate the solutions from the first example. Okay, and now, okay. Here is the carbon dioxide emission in 2010, and now the question is there evidence to show the mean carbon dioxide emission is lower than 2010 than in 2004 at 100 level? And now the answer is the mean is 4.87, and our non-hypothesis is the carbon dioxide emission, CO2 in 2010 is equal to carbon dioxide emission in 2004, and the non-hypothesis that will be okay, and the level is 0.01, sorry, 0.01. And now we need to calculate this one smaller. Okay, get it? The non-hypothesis assume the carbon dioxide emission from those 2 years are the same. But the alternative hypothesis, after their struggling, the carbon dioxide emission in the year of 2010 is less than the year in 2004 here. Okay, now how to calculate this? The same way, select and copy and move to our calculate. I would like to have a new spreadsheet. Okay, the same way. And now, the same way, there are several information here. 1, 2, 3, 4, 5, 6, 7. 7 times 4, that's 28. Minus 1, 2, 3, there will be 25. 25 data says here. Data says here. And first of all, try to find the mean. And the second one, find a sample standard deviation. Okay, how to calculate mean? How to get again? Click here the cell and move to the function equals average. And select the range. Oh, sorry. Oh, okay, great. Those three are not counted. Okay, no problem. Oh, good. Okay, and how about the sample standard deviation? Again, click this shell and move to the function. Click equal stdev dot s and select the range. Get it? Okay, and we try to reduce the decimals. Maybe one or two. How about two? Okay, we got the average carbon emission is here, 3.45, and the sample standard deviation is 2.97. And now the question is, test at 100% the level. Does it different from that one? Okay, the next we can calculate the t-value. The t-value look like this. T equals S bar minus mean and divided by sample standard deviation over the square root of n. The t-value, the t equals x bar minus mu and s divided by the square root of n. Let's calculate. X bar, that's here. .45, and the mean means here. The mean is 4.87. 4.87. And how about the standard deviation? Sample standard deviation, that is 2.97. 2.97, and the number square root of 25. Okay, and that would be 3.45 minus 4.87 and 2.9. Sorry. Okay, how to calculate this one? Similar way. 3.45 minus 4.87 divided by 2.97 and times square root of 25. Okay, get it? Okay, I will be quiet for 30 seconds. Please check the calculation here. Okay, click answer. The p-value is the t value minus 2.39. Approximately minus 2.39. Okay, and now I have a question. Does it fit the criteria? Does it fit the criteria? Let's check. As I shared the website to you, and now we know p-value calculator for t-distribution. The degree of freedom, 25 minus 1, that will be 24. T-value, we got the t-value is minus 2.3. 2.3, like this one. 0.9, okay. And calculate the p-value. Okay, at the kind of t value, t is minus 2.39, degree of freedom 24. Right here, past the p-value is 0.9875, and the p-value is not less than 0.01. Thus, no significant way to say the carbon emission in the year of 2010 is less than the year of 2004. Is it okay? Is it okay? Okay, you may feel confused about the principle of this one. Okay, let me explain here. Actually, you can consider the t-distribution, assume like this one. And here, our sample mean is 3.45. You can consider the mean here, 3.45 is the sample mean. And the standard deviation is 2 close to 3. Okay, we can see, okay. Plus 1 standard deviation, minus 1 standard deviation. Okay, and now what do you think about this one? Because the average is 4.787. The value here. Here is 6.42. Here is 0.48. And now the average carbon emission in the year of 2004, that is 4.87. This one. About this one. In other words, this kind of emission is close to the mean, not outside the standard deviation. Thus, according to the statistical analysis, no difference from that one. Is it okay? I think those questions are very similar. You need to learn how to calculate this one. And sure, I just demonstrated the question number one. Okay, how about I have a 10-minute break, then we can come back.